Okay, so the integral from 1 to 3. So remember that when you're working with area, the smaller number goes on the bottom and the bigger number goes on the top. Okay, and when are we going to integrate?
You start.
The function. Okay, now I did notice this on your guys' test. A lot of people just wrote it like this. Okay, I saw two things. Number one, you forgot the dx, which is a notational piece that says this is a function that's in terms of x. And the other thing is that you have to put this in parentheses. Okay, you always put the function, unless it's a single term, in parentheses, because we're going to integrate all this.
Right.
Okay, so I didn't take points for that, but I want you to think about it in the future. I might start taking points for that.
Or no parentheses.
Maybe. If I say it 100 times and you can't do it, then I'm going to start taking it.
I never remember you.
Oh, come on. Where else would you put them?
Around the x.
All right, so let's remember how to integrate. How do I integrate 2x squared? You add 1 to the exponent, and then you got to divide by that same number. So what is my first one? Good. 2/3 x to the third plus 3x. Okay, and I just integrated it, so I need to keep it in parentheses. And then there's this vertical line. Again, I saw a lot of this vertical lines in the wrong spot. Some people threw them in the front. Some people didn't write them at all. Okay, so that little vertical line means I just did an integral, and now I have to do a top minus bottom scenario. Garrett, put your phone away. Okay, so now what am I gonna do?
You're gonna plug in the 3 and then do that minus the.
Good. So I'm just gonna do the top minus the bottom. Okay, so we can pop this out, I think. So the first term is going to be 3 to the third, which is 27. But I have 27 being divided by 3. What's 27 divided by 3?
9.
9 times 2. So that first term gives me 18. 3 times 3 is 9. Okay, on that second term, or the first term of the second quantity, I have basically 1 to the third, which is 1. 1 times 2/3 is 2/3. And then 3 times 1.
Or 3.
So at this point, I would probably combine all my whole numbers. So I have 18 plus 9. So what's 18 plus 9?
27.
27 minus 3.
24.
So I have 24 minus 2/3. So you'd have to get a common denominator, which would be 24. What's 24 times 3? 12. 72. Nicely done. And then I can subtract the tops, and I get 70/3. Look at that. We did that all without a calculator. Okay, so if I was going to draw a picture to represent this scenario, I would have a parabola that's moved up 3 units, has a pretty skinny slope. Okay, it would exist from the x value of 1 to 3. Ooh, this isn't a perfect drawing, but you'll get the gist here. Okay, and so I'm just finding this area that exists between the function and the x-axis. So that area right there would be 70/3. Pretty good? Okay, so let's make this slightly more exciting. Let's now find the area between two curves. Let's call this example 2. I'm going to use that same, actually I'm going to make this a little bit nicer, function. And then we're going to go, let's see, let's just go x, we'll make it easy, between 1 and 3. Perfect. Okay, so I'm going to find the area that exists between my two functions. So I'm going to call them, let's call them y1 and y2. Okay, so first thing I'm going to do here is draw a picture, and then I want you to see what I might do here. Okay, so my y1, we'll draw that in blue. Okay, that one is up 3 units. It's a little bit steeper than the last one. And draw it not super steep because I want to be able to graph it. Okay. And then I'm going to go ahead and draw my y2 equation in green. So what does the equation x look like? Straight line, right through the origin. Very nice. Okay, so it goes right through like so. Okay, and if I'm only going to find the area that exists between the x values of 1 and 3, it's going to look like, let's see if I can get that 3. Okay, my area this time is just going to be right here, the area that exists between the two functions. So how is this going to be different than what I did on the last question?
Because, well, are you going to do the same thing but then subtract what's below?
Okay, so all I'm going to do is I'm going to take the area underneath the blue one, and I'm going to subtract out the area underneath the green one, right? Just like the warm-up today, right? Look at that correlation. Oh my gosh. Okay, so what I'm going to do, instead of doing this as two separate integrals, okay, so I can take the area of the blue one from 1 to 3, and subtract out the area underneath the green one. Sorry, that was a really curvy integral. Let me make it less curvy. Okay, so do you see where I'm coming up with this notation? Why I'm doing that? Okay, so now to make this easier algebraically, all I'm going to do is take the integral, since they're both between 1 and 3. I'm just going to make this as one integral from 1 to 3 and just do my top function minus my bottom function. Okay, so what I would write down in your notes, I'm going to slide off this really quick for a second. There's a little blurb in here about how to find the area between two curves. Where is it? Okay, and this is what I would write down for how to find the area between two curves. Okay, so if you have two functions, one being f of x and one being g of x, the easiest way for you to think of that is to always do the top function minus the bottom function. So the piece that I would recommend you writing in your notes is this piece right here. Okay, that one should make sense to your brain. You take the one that's on the top and subtract the one that's on the bottom.
What do you mean by top and bottom?
So like physically the one that's on top. So if I have an area, it'll always be bounded between an x and a y, but there'll be one function. It might be curved, it might be going crazy, but whatever's on the top minus the one that's on the bottom. Okay, did everybody write that down and circle it? From A to B, yep. A will always be your smaller number and B will be your bigger number when you're working with areas. Okay, so let's go back and finish that problem that we were working on and see what that area would be. If I can find it. Oh, there it is. Okay, so how would you go about doing this? Okay, so the first thing that I would do before I start to integrate is to combine like terms, and often you will be able to combine like terms. Can I combine like terms in this scenario? No, there's no like terms, so we're going to go straight into the integration piece. So what is the integral of 3x squared?
No, wait, that's 1
X to the third, right? Because the 3's cancel? Because I would have 3x to the third divided by 3. Good. Okay, what is the integral of 3? 3x. And what is the integral of negative x? Negative 1/2 x squared. Good. So I put that in parentheses because I just integrated it. Draw that vertical line from 3 to 1. Negative, okay, so because it's an invisible 1, right? So if I add 1 to the exponent, it becomes a 2, and so I have to divide by 2. Which is the same, dividing by 2 is the same as multiplying by half.
So if you put x over 2.
That would be fine. As long as it's x squared over 2.
Okay.
Yeah, that's fine. Alright, now what? Okay, so now I'm going to do top minus bottom. And this is the part that becomes pretty tedious. Okay, so we're going to go 3 to the third. Bless you. Plus 3 times 3 minus 1/2. 3 squared. Minus 1 to the third plus 3 times 1 minus. Okay, so this is where you grab your calculator and you type this in. Everybody got a calculator?
Of course.
Okay, you got the honors. Type it in. Let's see if we can all get the same answer.
All right.
Here we go.
Absolutely not.
Okay, you're typing it in basically exactly as you see it. You don't need the big brackets on the outside. If you want to type in values that are simplified, like if you want to type in 27 instead of 3 to the third, sometimes that's faster. I might type in 0.5 instead of 1/2 because it's less keystrokes. And all I can really tell you at this point is that we should have an area that is less than 70 thirds, right? Because 70 thirds was the area underneath the other one.
I got 28.
28 even? Okay.
Whoa.
Let's see if anybody else got 28.
I did not.
Maybe I
Oh.
typed it in.
You got what? Oh, 70 thirds. Yeah, 70 thirds is a lot.
Jeez.
23.
Give me a fraction, hit math fraction.
1114. 11 over 4.
111 over 4.
I got 27.
I saw that.
Hit math fraction for
Okay,
me.
I need to do
I want fractions.
1
over 4. Okay, I got a couple 111s over 4. Is everybody able to get that same answer?
Hold on.
Okay, so do you see where this becomes a little bit scary? This part where you have to type in this piece, you have to type it in correctly. Okay, there's a lot of room for error.
Yeah, and I was like, I got 28. Yeah, math.
Okay, those values are too high though, because 70 thirds is 23.
Got 36.
Don't do that. I'm gonna have to leave my area after you. Puke? Yeah, dude. Gross. I don't see a mistake on this.
Yeah, I don't either.
Hmm.
You're checking it.
Okay, my turn.
Yeah, I got
You're getting 28 also? Okay, I'm gonna do it my way and see if you guys agree with my way. Okay, so first term I see is 27. Do you agree with that number? Plus 9 minus, I probably would type this in as, well, yeah, or I could say that 3 squared is 9, and that would be 9/2 on that fraction. That way you don't have to type as much stuff. And the parenthesis, minus, another parenthesis, 1 plus 3, what's the last number, minus 1/2? Minus 1/2. So I got 28.
But that doesn't make sense with the other one, because 70 thirds is 23 and a third. So how is
23 and a third?
Yeah. So
Oh, I know why, because I switched the original equation. I switched the exponent or the constant in front. I should have used the same ones, but I didn't. Because I wanted to make it easier to integrate. So 28. So did people who got 11/4 figure out what you did wrong?
No.
Let me see your calculator. So Tori got the same thing, so probably. Oh, you have a 0.5 squared.
Yeah.
It's not, only the 1 is squared. So that the very last term should just be 1. Did you guys find it?
Wait, 1/2. Oh.
So what Tori did, so I'm assuming that would be what you guys did. Make sure that just the 1 right there is squared, not the 1/2. Okay. All right. Yeah, no. It's like one answer is right and one is wrong. It's like, no.
By the way, that's only $1/4 $1.
So how do you feel about this? Do you like this? Not too bad? Okay, we're going to start this together. And because there's going to be some stuff where it's going to get harder.
Oh.
Or like if we have one up or something.
By all means. All the colors? Yeah, you're like, oh, I got green. I picked some really got pretty pictures. Yeah.
So when it says x equals 1 and x equals 4, is that like the parenthesis or the bracket thing?
Yeah, that's your interval, yeah. Okay. You found a mistake? Okay, put your phones away, grab your worksheet, grab your pencils. If you got colored pencils, that's probably a good thing to do. Or pens or something. When you draw this, it becomes really helpful to have some coloring to identify what's top, what's bottom, because at some point we're going to get some functions that are going to cross in between the intervals, and it's going to get exciting. No crying. Suck it up, Buttercup. All right. So, I don't want this to be like incredibly tedious to where we're like graphing everything by hand. Okay, I know I've given you tests on how to graph quadratic pieces and linear pieces, so I want you to start by using your calculators. Okay, so grab your calculator. I want you to type these two equations in, and we're going to use our calculator to help us draw these functions. Yeah, this is yeah, I've given you guys tests on all this stuff, so you know what you're doing. You know what this should look like. It's a parabola. It's up 14 units. It's slid to the right. And then we got negative 0.5x. This one's a linear function. That's down 4 with a slope of 1/2, right? Okay, so make sure you hit zoom 6 or you're in a standard 10 by 10. That's pretty close to the graph that we have here. Okay, so the first thing that I want to do is I want to try to graph this pretty accurately. Okay, I know that I'm going between 1 and 4, right? Okay, so it kind of looks like that bottom piece. 1, 2, 3. It looks like it goes down. Like if we would trace our graph, you guys hit trace, you can kind of go on the function and we can get pretty close. So I don't want to spend a ton of time making these perfectly accurate.
Hey, Nancy, I got an error.
Make sure you typed like when you typed in the second one, make sure you use the negative button as opposed to the minus.
What did you do?
So,
What's that? Second graph. What? Oh, or you can use your table. Absolutely. Perfect. Yes. That's a good idea. I like your idea.
That's how I do it.
Am I like zoomed out?
Ooh, look at how far I am. Yeah, hoops, zooms in. Ooh.
Oh, there we go.
If you go into, let's go to 0. So 1, 7. Is that how you always do it?
Yeah.
Oh, you guys are so smart.
Wait, what do you do?
If you hit second graph, it'll give you the points too. All right, so my purple equation is our first equation. I would call that like your y1. And then I'm going to draw my other equation in red. Okay, that one's going to be down 4, slope of down 1 over 2.
How did you get it so that your table was in one?
If you hit second window, you have your start value and then your table goes by ones. Okay. That looks good. Okay, so this is going to be bounded by the x of 1 and 4. Okay, so our area is right here. Okay, so you ready for the integral? You're going to have to write small here. All right, so I'm going to do my integral. So my integral goes between which two x values? The integral from the lowest x value to the highest x value. So that was a question.
What?
Between which two x values?
1 and 4.
There we go. Between 1 and 4. So I go 1 to 4. Okay, and then I'm going to do my top function. Which equation is on the top?
The left one.
Okay, so the quadratic one, right? So we're going to have x squared minus 8x plus 14. And we're going to subtract the bottom equation. So what's the equation of the bottom one? Negative 1/2 x minus 4, right? Dx. Did you write your notation correctly? Be very careful with parentheses. I like to write brackets instead of parentheses because I feel like brackets look different than parentheses, so therefore are less confusing. But that's just my opinion. Okay, so before I integrate, I'm going to combine like terms. So how many x squareds do I have? I have 1, so I have x squared. How many x's do I have? If I have negative 8x minus negative 1/2. So negative 8 plus 1/2.
Oh,
Plus 1/2. So negative 7.5, but I like fractions, so what's negative 7.5 the same as? 15 halves. So negative 15 halves, good. Okay, and then what's my constant? What's 14 minus negative 4? Plus 18, good. Okay, so there's our function that we're now going to integrate. Okay, so what is the integral of x squared? So 1/3 x to the third. Okay, be careful here. What is the integral of 15 halves x? Can you do that in your head? It's going to be divided by 2, which is going to multiply the bottom number by 2. 15/4, good. So 15/4 x squared. And what's the integral of 18? 18x. Okay, so after you integrate, you're going to use parentheses. Use that vertical line from 4 to 1. Okay, at this point, what do we do? Okay, so we're going to plug in the 4. So I'm going to use my brackets again. So we're going to go 1/3 times 4 to the third minus 15/4 times 4 squared plus 18 times 4 minus 1/3 times 1 to the third minus 15/4 times 1 squared plus 18 times 1. I guess I don't need my big brackety. Okay, and then you grab your calculator and very carefully type that in.
Hello.
Hello? Did you get 75 over 4? Anybody else get that? Okay, verification. Excellent, and that's what I got too. Everybody able to get that? Good.
What's gonna see?
Oh, did you switch your tardy? Sure. Okay, let's do question number 3 together because this is the one where it gets exciting. Yes, I said exciting. That's what I meant, exciting.
So exciting for math teachers or exciting for students?
Exciting for just everyone. It's exciting. All right, so question number 3, I'm going to start this off the same way I did the last question. I'm going to throw this into the calculator, and I'm going to use Garrett's awesome trick of using the tables to graph this correctly. So I have 0.5 x squared plus x minus number 3, 11 halves. Okay, y equals 2. I'm just going to type in 2. That one, I don't really need a calculator to draw, but oh, this is not the one I was thinking it was. Sorry, this was not the one I was thinking it was, but that's okay. We can still do it. It's not as exciting as I thought it was. Okay, so what are the points we got? So we're going from -1. I'm going to go up so I can get those points down here. -1 is at -6. Why is it not drawing? Well, that's annoying. Oh, there we go. Hello. What else do I got? Can you guys tell me the points? Is that the lowest one? There we go. I'll just draw like this. That looks perfect. Excellent. Y equals 2 is like right there. And we're going between, -6. Let's make sure at -6 that we are definitely below. Ooh. -5 is at 2. Okay, that's important. -5 is at 2. So what's -6 at? 6. Actually, this will just work. 6.5. Oh.
All right,
So this equation is going to be good. This is all right. We're good. There we go. That looks perfect. Okay, so we're going between -6. So do you see between -6 and -5 that the blue function is on the top? You see that? So we have like this slice. And then between -5 and then we're going to what? -1? Then it like switches. So guess what in this scenario? We end up with 2 separate areas. Which guess what that means when we set up our integrals? 2 different integrals. That looks real. Oh. How? What's that? Ah. What'd you say?
They haven't made an announcement.
Okay. Bad words are not allowed. Okay, so I'm going to change this top little sliver to a purple color just so you can verify which region I'm talking about. Actually, that looks pretty close to blue. Okay, do you see my purple and my blue regions? Can you tell the difference on that?
Yeah.
With the color? Okay, so I have to set this up as two separate integrals. Are you ready? Everybody focus. It's going to be a lot of writing, so write little. Okay, you ready? Okay, so for my purple region, what does that area exist between? Which two x values? Good. So -6 to -5. Okay, in that purple region, which function is on the top? Which function? The x squared one, right? So it goes, what is that one? So 1/2 x squared plus x minus 11 halves. So then I'm going to subtract. Oh, every time I write 11, I always write pi. Yeah. Okay, so then I'm going to subtract the horizontal line of 2. Does everybody follow that? Dx. Okay, and then I have to talk about the blue area. Okay, so I'm going to add the blue area to my purple area. We're going to add those two areas to find the total area. So to set up my area for the blue, what does that integral exist between?
-5 and
-1, good. Okay, and on the blue region, which function is on the top?
The 2.
The 2. And then I have to subtract 1/2 x squared plus x minus 11 halves. Everybody get that? Dx. Okay, so I'm going to start by just working with the purple. Okay. So on the purple, the very first thing that I should do is combine my like terms, right? Sam, what are you doing? I know it's not that interesting. Okay, can I combine my like terms on my purple? Okay, so what is -11 halves minus 2? So 2 would be the same as 4 halves. So it's -11 halves minus 4. So -11 minus 4, 15 halves dx. Okay, now I'm going to integrate each term, and I expect to see this on your papers. I want to see your practice of how to integrate. So what is the integral of 1/2 x squared? Can you do that in your head? 1/2 x squared, what's the integral? 1/6 x to the third. And what is the integral of x? 1/2 x squared. And what is the integral of -15 halves? Just add the x. -15 halves x. There's no x with it.
never mind.
Okay, make sure you put that in parentheses, and you're going to go from -5 to 6. Okay, I want you to stop there. We're going to move over to the blue function because I'm going to show you a trick after we do this blue side. Okay. Okay, so on the blue side, the first thing I'm going to do is combine my like terms. Okay, and I want you to notice something about what happens on this other one. Okay, so we're going to distribute that negative through, so how many x squares am I going to have? -1/2. How many x's am I going to have? -1. Okay, and my constant is going to be 2 minus negative, which is the same as plus, 2 plus 11 halves. 15 halves. Do you guys see what happens between that purple equation and the blue equation there when we switched it? They're exact opposites. That's going to happen every time. If we do a top function minus a bottom function, one will be positive, and if it happens to switch and do the bottom minus the top, it'll always be the negative version of that. Okay, so that becomes a nice little trick. It does not turn out to be 0 because our integral bounds are different on each integral. So that will be different. Okay, so now we're going to integrate it. So what is the integral of negative 1/2 x squared? Negative 1/6 x to the third. What is the integral of x? 1/2 x squared. And what is the integral of 15 halves? 15 halves x. Okay, I need my line from negative 1 to 5. All right, you guys ready for my trick? Oh, yes. Okay, so you can do integrals in the calculator. Okay, so I'm going to show you how to use integrals in the calculator so that you can be sure that you're getting correct answers. But I expect, is everybody listening?
Yes.
I expect for you to still be showing your steps between top minus bottom, and I want to see that integration step before you type it into the calculator. Okay, do you see what I'm saying by that? You have to show that to me. Okay, so what I can do though is I can type the integral straight into the calculator. So do you see my purple middle step, the middle one? That's the one I'm going to type into the calculator. So if I hit, whoops, alpha window, you might want to do this with me, alpha window, that fourth option down gives us an integral, and this only works for a defined integral. If I don't have a bound, it doesn't work. The calculator is not that smart. Okay, so I'm going to go negative 6 on the bottom to negative 5. Okay, and then I'm going to type in our function. So we have 0.5 x squared plus x minus, and I'm going to type my fraction in, 15 halves. And then you have to do that at the very end. There's a little spot for you to type in what variable we're talking about. That's our notational dx. You got to type an x right there. And then you just hit enter. Okay, remember that we want fractions. Whoops, my bad. So all you're going to do after that is hit math frac. And did everybody get 13/6? Yep. So if you do it by hand, you'll get the same answer. So you have to do top, bottom, bottom. There's not a way to do that integral symbol. So you would have to type it in as plugging in negative 5 and then plug in negative 6. Yes. Alpha, window, and number 4. Okay, so your turn. I want you to do the blue region. Tell me what you get. Okay, everybody should be typing on their calculators. I want you to do the blue one. So you should be typing in this little statement right here into your calculator. Yep, you gotta type the dx. Okay, would it make sense for us to get a negative? So think about this in your brain. Would it make sense for us to ever get a negative number?
Yeah. Below the x-axis.
Okay, but we're talking about area that exists between two functions. So no. So it is possible to get a negative area if we're talking about one single function and it does exist below the x-axis. That is a possibility. But if we're talking about area that exists between two things, that'll always be a positive number. So if you ever get a negative number on this stuff, then something went wrong. You should be getting positive numbers. So what did we get? Positive?
Yeah, that's what I got.
64 thirds.
I got a negative.
64 thirds. Are we okay there?
I got that.
Okay, and then add those two numbers together and tell me what our total area is. So what is,
Wait, how did you get that? I got
what is the total? Anybody total?
47 points.
47 halves? Thank you.
Oh, I forgot to hit
Oh,
that.
that's easy. Okay, do we got this? Do we need to do another one where they switch like this and we have a top minus bottom and then they intersect for the first setup?
No, okay, I just have a quick question. So, on number 2, the line is on top of the equation, so am I doing that equation minus the grapple equation? Oh,
Yep, it's always top minus bottom, whichever one is on the top. Okay, so you guys want to do number 4 and at least just set up the integral because this one probably is going to intersect within our little
Is there anything on
piece.
the back?
No, this is all the same stuff. Okay, so let's set up number 4 together.
Wait, what was the ending answer?
47 halves.
Okay.
All right, you ready?
Oh boy,
So
this
first
one's
thing we want to do is we want to draw it. We want to see what this looks like because do you guys see why graphing this becomes really important? Why do we care about the graphs? Why am I making you graph these?
See which one's on top.
So you can see, and what are we looking at? We got to see which one is on the top and which one is on the bottom, right? That is very important. All right, so I'm going to hit graph. We got an upside down parabola for the first equation. Oh my gosh, and another skinny upside down parabola. Okay, so I'm going to use the table and draw some points here. So we got negative 6, 2. Wait, negative 6, negative 2. Negative 2? And then it looks like it maxes out at negative 4, 4. Oh, yep. Thank you. So that's going to go there. And we need to get to 0. 0 goes to negative 4. So something like that. So that's my first equation. I'm going to call that my y1. So this is in blue. Now I'm going to do my second equation in red. Call it my... So that one looks like it maxes out at negative 0.54. Crosses at 2, negative 2, 2. 0, 2.
Wait, so those share?
Yes, and that's very important too, because we want to know where these two functions intersect. Okay, we're going from negative 3 to 0. So I'm going to do 2 different colors here. Let's do a blue. Ooh, well, blue. And green.
Colors definitely help.
Yeah, right? So kind of doing this on OneNote is kind of nice, as Cassie pointed out earlier. Okay. So it becomes really important for us to know where these two functions intersect, right? Negative 3 to 0. See right there?
Yeah, but like we don't do like that little part.
That little, oh, the little sliver underneath? Yeah. No, because we're looking for the area in between the two functions. We're finding area that exists between them. No, it's not bounded because that would be bounded by the x-axis. Okay, so where do these two functions intersect? What x value? Okay, So if you can't figure out how to find that on the calculator, how would we do that algebraically? How do you find where two functions intersect if we were going to do that algebraically? The second one, Rom?
Oh yeah, one goes up and one goes down.
What?
Look at the graph.
They're both going down.
Oh, what?
Yeah.
Oh, one of my red one is the x-axis is not perfect.
What?
It's not perfect, but it still is okay. It's a little too fat. You're right. On my 2 points on the right here are a little off. So it should be, what was it? So 0, -4. No. 0, 2, my bad.
Oh, I didn't do negative.
So it should actually be more like. Is that okay? You're right. I wasn't very perfect. So we'll do. So this blue area is actually bigger than I drew it out to be. How's that? Do you like that better? A little bit better? It looks more like wings of an angel. Okay. So let's start by finding setting up the integral for the blue area. Okay, so what are the two x values that bind our blue area?
0 and negative. Oh wait, yours is
Blue, the left one. So what binds my blue area? What x values?
negative.
Okay, remember the lower one goes on the bottom, so -3 to -2. Okay, when I set this up, I have to do top minus bottom. So what is my top equation?
It's the negative x.
It's the negative, which one? They're both negative x squared.
Y1.
The y1, the blue one, right. So it's going to be -1/2 x squared minus 4x minus 4. And we're going to subtract the red one. The red one is on the bottom there. Whoops. -2x squared minus 4x plus 2 dx. Okay, so let's just really quickly simplify that because that looks so giant and scary. Let's simplify it. So if I combine my like terms, how many x squareds do I have? Okay, so it's -1/2 minus -2. So that would be the same as -1/2 plus 2. Okay, so 1.5, which is 3 halves. Okay, what about my x? What's -4x minus -4x? Right, so -4 plus 4 is 0. So those go away. That's nice. What about my constant? What's -4 minus 2? -6. Good. So that looks way nicer. Isn't it? All right, now let's do the green area. We'll set up that integral. Okay, so what does my green integral exist between? Which two x values?
Oh.
Well, I don't have that much space on my key.
You should use OneNote. Sorry.
You will not be able to read my.
Okay, what does the x value exist between? Good. Yep, you got to add the two areas together. Okay, so what is the top one of the green function? The red one, right? So the red equation goes -2x squared minus 4x plus 2. And we're going to subtract the blue one. Oh my gosh. -1/2 x squared minus 4x minus 4. Okay, and then we're going to add our like terms, so this gets a little nicer. Okay, if we add our x squareds together, what's negative 2 plus 1/2? Okay, what happens to my x's? Negative 4 plus 4. Cancel. And what about my constant? 2 plus 4. Plus 6. And do you see that trick? Do you see the difference between the blue equation and the green equation right there? Okay. So now I expect for you to integrate without using your calculator right here. I want you to practice the integration piece. Okay, because technically they're going to be the same, right? One's just going to be positive, one's going to be negative, so it's not too complicated. So, what is the integral of 3/2 x to the third? Yeah, is that what you said? 1/2 x to the third. What is the integral of 6? 6x. We put that in parentheses. Make a vertical line from -2 to -3. Okay, we're going to integrate the green one as well. Okay, what's the integral of -3/2 x squared? -1/2 x to the third. Integral of 6? 6x from 0 to -2. And now I'll let you use your calculator. Okay, so when you get the blue area, let me know what you got for the blue area. What's that? Because you're doing derivative. Do integral. So do the next one down. It says f int. You got what? 3.5. Can you hit that as a fraction, even though I can probably convert that as a fraction? What is that, 7/2? Okay, what'd you get for the green area? No, we'll never get a negative number. Because the bounds are different. That's why you'll always get different values. Top minus bottom. 8? Exactly 8? Is that what everybody else got? 8? So right now we're typing in like this one right here into the calculator. So doing the integral of, yeah, you can't do the second line because there's not a way to do the top minus bottom, that second integral step. Okay. If there was, I would have you do that. Okay. But
typed it in right. Hold on. It's just not
you got an error? Double check and make sure your negative at the very beginning is a minus as opposed to a negative. 3.5? 3.5? Yeah, that's the same as 7. 3.5. Oh no. So total would be 1623 halves, right? Okay, so I would prefer that you guys give me fraction values. It's not too hard to hit math frac for all that. Alright, so I am finished doing this with you. The rest is yours.